on an investment project which is expected to be analyzed using appropriate discounting technique of net present value. So in this case, we need to prepare a table for the purpose of setting up the convenient calculations with a view to compute the appropriate value of our net present value. So from this particular question now, we can put it in mathematical form. We have years, we have year 0, year 1, year 2, and year 3. So the machine is expected to cost 120,000 naira, which means our year 0, which is initial cost, it will be 120,000 naira. The initial cost can be represented by year 0. Then in the year 1, we have the inflows to be 45,000, we have 60,000, and we have 50,000 naira. Whereas our rate of discount or discount rate is assumed to be 10%, which is 0.1. That is our discount rate, is said to be 0.1. So let's do this as appropriate. So in doing this now, we have once again, we have our years, which are said to be 0, 1, 2, 3. We have years 0 to 3, and we have the cash flow, which is given for year 0. We have 120,000. We always put the value in year 0 in bracket because of the fact that it represents the initial capital outlay. Then in year 1, we have the profit to be 45,000. In year 2, we have 60,000. In year 3, we have 50,000. Then we have our discounting factor at 10%. Discounting factor at 10%, we have to use. Don't forget, the discounting factor formula is equals to 1 over 1 plus r raised to power n. That is the discounting factor formula. So there are two ways by which we can obtain our discounting factor at any given percent. One, we have what we call a statistical table, where we can easily get discounting factor for various discount rates in percentage. Or better still, we can compute it manually using appropriate formula, which I have given us as 1 over 1 plus r raised to power n. We do that for each of the years involved. For example, let me show our working calculation. So let me show the working calculation here. So working calculation. So we have for year 0, and that will be 1 over 1 plus r raised to power n, which is 1 over 1 plus our r is 0.1, which is 10%. 0.1 raised to power 0, and that's 1 over 1.1 raised to power 0, which is 1 over 1, and that is 1. Then for year 1, we have 1 over 1 plus 0.1 raised to power 1, which is 1 over 1.1 raised to power 1, and that's 1 over 1.1. Then we have 1 divided by 1.1. This is equals to 0.9091. Then for year 2, we have 1 over 1 plus 0.1 raised to power 2, which is 1 over 1.1 raised to power 2, which is 1 over, we have 1.1 raised to the power of 2, and this is equals to 1.21. So we now have 1 divided by 1.21. This is equals to 0.8264. Then year 3, we have 1 over 1 plus 0.1 raised to power 3. That's 1 over 1.1 raised to power 3. That will be 1 over, we have 1.1 raised to the power of 3. And this is 1.331. We now have 1 divided by 1.331. This is equals to 0.7513. So now, these are the discounting factors which we have to bring here. For year 0 is 1. For year 1 is 0.9091. For year 2 is 0.82, 0.8264, 0.8264, and year 3 0.7513. So that is what we have. Then we can have discounting cash flow now. We have discounting factor times cash flow. That will be 120,000 times 1. We have 120,000. Then we have 45,000 times 0.9091, which is equals to 40. We have 45,000 times 0.9091. 9091. This is equals to 40,910 naira. 40,910. Then we have 60,000 times 0.8264. This is equals to 49,584. Then we have 50,000 times 0.7513. This is equals to 37,565. This is what we have our discounting factor. So now, don't forget our NPV, like I said. NPV is equals to summation A over 1 plus R raised to power N minus C naught. So which means all this one now, they are going to, or better still, we can put it as NPV is equals to gross present value minus C naught. So from years 1 to 3 can be represented as our gross present value. Then C naught is what? Discounting cash flow for year 0. So now I can have 40,910 plus 49,584 plus 37,565. And this is equals to, we have 128,000. So to now get our net present value, I said is gross present value minus C naught, which is year 0. But here, let me just take note of the fact that we were told at the end of the useful life, which is year 3, the machine would have a scrap value of 10,000 naira. So we have to consider this or take this into account, and which means that at the end of the useful life of the project, which is year 3, then to now get the exact cash flow for year 3, we need to add this particular 10,000 naira scrap value to the inflows in year 3, which means that in year 3, we are going to have the sum of 50,000 naira. That's 50,000 naira plus 10,000 naira scrap value, which is now representing 60,000 naira for useful life in that of year 3. So automatically, the discounting cash flow will change because we are going to multiply the discounting factor at 10%, which is 0.7513, by the inflows now, which is 60,000 naira. And this will give us 45,078. 45,078. So please, we have to take note of the scrap value, which is expected to be added to the project at the end of the useful life, which is that of year 3. So in other words, the formula still the same as net present value is gross present value minus C naught, and the discounting cash flow for years 1 to 3 will now represent our gross present value. In other words, we have 40,910 plus 49,584 plus 45,078. And this is equals to, we have this as 135,572 minus initial capital outlay, which is 120,000 naira. So we have 135,572 minus 120,000 This is equals to 15,572 naira. 15,572 naira. So the value we have gotten for MPV is actually positive, and it is 15,572 naira. Then let's look at how to interpret the result we have obtained using the net present value. The usual rule of MPV is that if MPV is greater than 0, the implication is that the project is worthwhile and accepted. If MPV is equal to 0, the project actually breaks even. And don't forget the fact that if the value of MPV of a project is equal to 0, automatically it implies that break-even has actually been achieved. And it must be noted here that if the project is executed by private individuals, such project may not be accepted, because the objective of private individuals in establishing a project in the first instance is to maximize profits. On the other hand, if it is a project that is executed by the state or government, government can go ahead with the project, because government is not out to make profit, but rather to provide essential services and improve the welfare of the populace. Then finally, if MPV is less than 0, then the project is not considered worthwhile, and as a matter of fact, such project must be rejected. So all these are the ways the values of MPV can be interpreted as appropriate. So from this particular question now, our MPV is equals to 15,572 naira, and this is positive, which implies that the project is worthwhile, and as a matter of fact, it should be accepted.